Would you like to introduce yourself to our audience, right,
Yeah,
as to what your
definitely.
role is?
Hi, everyone. My name is Ram Trachur. I head the global semiconductor market strategy for Henkel Corporation.
So, coming to Henkel now, how would you explain your division solutions to a non-technical CEO of a customer firm who's interested only in numbers, profits, etc.?
Yeah. First, I would say Henkel is a trusted material partner that has both breadth and depth in the portfolio. We serve a wide variety of verticals: automotive, industrial, consumer electronics, communications, mobile communications, all that. And also, we have a large portfolio of materials covering family of adhesives, underfills, thermals. So with this, we offer them a complete solution to their manufacturing. And secondly, I would want to instill confidence in the CEO by saying that Henkel has been supporting electronics and semiconductor manufacturing for more than 50 years. And we have a global footprint, global manufacturing and innovation, and we can be a very reliable manufacturing partner, easing off the pressure when you're running in full speed.
To the R&D head, the CTO, who's more interested in the technology and the strategic advantages there.
Yeah, totally. Yeah. So, with our strong capability in material development, over the years, we have developed the ability to have what I call as predictive innovation. We work with our customers to understand the end market trends. We translate the end market trends into device level or system level trends. And then we translate that system level, device level trends into how does it impact package architectures for semiconductors. And then we further understand, oh, if these are the package architectures that are demanded for to support these new trends, what are the pain points the customers needs to solve? And then in the end, we translate that pain points into material development opportunities. So we kind of like don't wait for the customer to ask for a material, because by that time we are too late to serve the market. So we proactively understand end market trends, translate that into material needs, and have a real conversation with the customer, telling them that, hey, these are the things that we believe you need to solve in your roadmap. Are these right? We have a conversation with the customer. And then we also have huge innovation investments in both wire bond packaging, advanced packaging within our core areas, and also exploration outside of our core. So in that way, we can tickle any innovation mindset by not just serving their current needs, but also addressing their future needs.
Is there any R&D or manufacturing happening in India?
So Henkel is a very big company, and we have many different business units.
Right.
So we have a strong manufacturing presence in India.
Yeah.
And more recently, we have added electronic materials manufacturing capability in India to support our local customers.
So with about 8 to 10 plants, semiconductor plants announced in India, you see India to be a big enough market for brands like Henkel to be excited?
Yeah, 8 to 10 plants. I think that's very exciting for Henkel, because this gives an opportunity for our customers here to focus both on wire bond packaging business opportunity and also advanced packaging business opportunity. And with 8 to 10 plants, that also gives a pretty strong head start for the semiconductor ecosystem in India. And we already see memory manufacturers, OSATs, power semiconductor players, all that having a footprint in India. And our portfolio in Henkel is very well aligned to the products that are being made in India. So yeah, obviously it's a very exciting opportunity for Henkel.
So you are seeing all the global markets with respect to the semicon ecosystem. How do you see India's evolution in this ecosystem?
Yeah, so we've been participating in India ecosystem, supporting electronics manufacturing and more recently also semiconductor manufacturing. And I'm actually very excited to see the growth because there are many angles for India to be successful. First and foremost is the geopolitical diversification. I think India plays a unique role in ensuring supply stability for global semiconductor manufacturing. And then the next big thing I see is self-sufficiency because India on its own could be quite a big market. So in both of these angles, I think India has a bright path for semiconductor manufacturing success.
On your global exposure, how do you see India's semicon ecosystem evolving from here? Do you see it following similar path as other nations, or do you think there could be a twist here?
Yeah, interesting question. Yeah, so I think India has a lot of learning opportunity from previous ecosystem developments, be it Korea, be it Taiwan, China, or even Vietnam. There is a lot of lessons learned, but that's only an opportunity for India to accelerate even more. So could there be a twist? I'm unable to predict the future, but the recent geopolitics, I think, could favor India because most nations may see India as a favorable, more stable country for starting production. And then India's own market could drive demand, and Indian government policies could trigger self-sufficiency initiatives that could accelerate the manufacturing in India.
So how do you see India being ready to create such talent, such specialized talent, and any initiatives at Henkel's end to tie up with academia to build that talent?
Yeah, so if you see the world's landscape of semiconductor talent, you will see many leading or executives in semiconductor industry are actually of Indian origin, which is a testament to the foundational education system in India. So I think that is still the hottest commodity in India. The schools, the colleges, they all provide richness in talent. And I think that is the least of India's problems when we start semiconductor manufacturing. But obviously, all this talent needs to be bridged, upskilled to be capable in semiconductor ecosystem. So there are many upskilling programs, initiatives that the government is doing with a combination of external expertise. So I think that's very strong. And as far as Henkel, we are in the process of exploring tie-ups with academic institutions in India to see how we can leverage the strength to actually bring in talent in India. But while we are developing our team, within Henkel, we have programs globally to upskill any employee that's onboarded in India. We have a global team of engineers and scientists who have a lot of depth in semiconductor packaging, whereby we upskill our local talent in semiconductors.
Those wanted to build their careers in this semicon packaging ecosystem. What are the skill sets they need to master?
Yeah, so in semiconductor packaging, it is really a multi-specialty area. So we need expertise in material science, we need expertise in electrical engineering, electronics engineering, chemical engineering, and all of this in combination will help to understand a semiconductor packaging process flow. On top of this, I would also recommend strength in foundational skill sets of problem solving, critical thinking, having an analytical mindset, attention to details, and also a lifelong curiosity to learn new things and break new boundaries. I would say these are some of the critical skill sets required in semiconductor to be a successful engineer in semiconductor packaging.
Wow. So how's AI affecting as a resource the semiconductor packaging?
AI has indeed transformed semiconductor packaging, not just in terms of the architectures that are needed to support AI, but also the value semiconductor packaging has created to support AI systems that are deployed in the market. So I want to explain this as what was semiconductor packaging pre-AI era and what is semiconductor packaging in the AI era. So in the pre-AI era versus in the AI era, we can compare that along the lines of the power demanded by the semiconductor chips in terms of the logic or silicon area that is involved in the compute processes, and also in terms of the thermal dissipation that is needed or challenges that is present in the AI chips. And in the AI era, our customers also are innovating at a much faster rate, releasing products for supporting AI at a much faster rate. So we see a need for accelerated material development to support AI-based chip architectures on top of all this.
So how's AI affecting as a resource the semiconductor packaging?
So AI as a resource, probably I'll answer this from my customer's perspective. I believe AI as a resource will impact chip design. It will impact any repetitive process flows that are used in manufacturing. It will impact logistics operation, probably any predictive maintenance that needs to be done. And also, it catalyzes innovation in general across all processes. So that's where we see the biggest impact of AI.
Okay, and how is it affecting as a market with all the new chips coming in?
I think I may need another hour to kind of cover this. But to give you a gist, Henkel is focused on providing wire bond packaging solutions and advanced packaging solutions. And both of these areas are very innovation heavy, meaning we have to have a very strong roadmap to support our customers. So as an example, in wire bond packaging, the biggest trend that we see now is electrification and the emergence of power electronics that use wide bandgap semiconductors. So we have innovation programs to support our high thermal die attach materials with both sintering or pressureless sintering and pressure assisted sintering to enable discrete power electronics devices and also power modules, which we believe will be very important in industrial automation, in traction, and also in general electrification. And then in advanced packaging, most of the innovation is driven by the need for supporting AI-based semiconductor architectures. Here, we are investing in our adhesive portfolio, our underfill portfolio, and also our encapsulation portfolio. In all of this, we're adding a thermal element because of the increase in power consumption in all these devices and the need for reducing extracting the heat, there's all these materials need to contribute towards spreading the heat and extracting the heat. So we have a lot of innovation within this core, and we're also exploring co-packaged optics, where we are developing light path adhesives with semiconductor grade reliability functions. And then we are also investing in liquid compression molding materials to enable panel level interposer fabrication. As the interposer moves from current wafer level format to a panel format, there are new needs for materials, and we're innovating in those areas.
Wow, that's a pretty long list.
That is, yeah.
So when I looked at your website, this term co-engineering kept popping up, very interesting phrase. So what does it mean with respect to, ATMP, OSAT, IDM, substrate maker, etc.?
Yeah, so the co-engineering aspect is mainly our call to be a collaborative partner with our customers, because we realized early on that just us innovating on materials, following specs, is not going to help solve the problems for our customers. So we really want to take a collaborative approach in problem solving. So maybe I can highlight two examples of co-engineering. One in, I would say, traditional wire bond packaging for like a power module device, and the other one is in advanced packaging for an AI device. And though these two are two different material categories. So in power modules, we are now developing pressure-assisted sintering material to enable a die-to-sub sintering and substrate-to-base plate sintering or large area sintering. So here, we're coming out with a new category of materials called copper-based pressure-assisted sintering materials. So whenever we come out with these new material categories, we have to engage pretty much the whole ecosystem. A customer is a very important piece, a central piece of this. We engage the tool suppliers who help us test our materials, develop the processes. We engage the lead frame suppliers or the substrate makers because we need to attach to different interfaces in the substrates. And we also engage testing partners because often these power modules need to go through power cycle testing and the special capabilities that we need to engage. So multi-parties, we collaborate together and bring a solution to the market. And not just that, because power module makers now are part of a global ecosystem, there's large companies in China, in Europe, in Asia, ex-China that are all involved. Now we also have to develop capabilities at multiple locations for this interface and really collaborate at all these different geographical regions. So that is one example. And the other example I want to highlight is in our advanced packaging, which involves the development of wafer level and panel level liquid compression molding materials. These are new classes of materials now used to encapsulate 2.5D and 3D package structures at both the 2.5D assembly level and also interposer level. So when we develop materials like this, we often encounter challenges not just to process the material using an equipment. So obviously, we'll have to work with equipment players, but we'll also need our customer support to validate, hey, whether the process we develop is actually defect-free in their inspection, in their electrical testing. So we depend on the customer. And also we depend on our co-material suppliers because this liquid compression molding material often touches other categories of materials like polyimides, for example. So we need to ensure compatibility. We need to ensure compatibility in back grinding processes. So it's kind of a whole ecosystem working together to collaboratively, to provide a solution for our customer.
Should the team connect with Henkel's team, right? At the R&D stage or the manufacturing stage of the overall semiconductor life cycle?
Yeah, so normally our customers like to stick with the bill of materials that was originally instituted when the first manufacturing happened. There is a lot of stickiness of BOM in semiconductor packaging. So as a material supplier, we'd like to engage very early on, especially if a customer is making new product introductions, new design changes that impact package architecture. We'd like to involve early on in the design so we can understand what are the materials we need to develop or that can cater the new design parameters. So often we engage during the design stage, but there are also instances during manufacturing the customer may seek incremental opportunities for improving either the product performance or the manufacturing efficiency. And there are opportunities where even we engage with the integration team or the process development team at a later stage to offer incremental improvements.
So customers can call your team and expect them to help them with process improvement or even cost reduction, etc.
Totally. All of our customer pain points are things that we like to resolve, be it operational challenges, be it total cost of ownership challenges, or very challenging innovation problems that brings a new material into the market. These are all within our capability to address.
So does that mean that the typical point of entry is generally the R&D or the new product development teams in the semiconductor ecosystem?
That is correct. In most cases, we want to be in at the early stage when the customer needs the material. And if I look inside a customer's organization, there are many different teams. It could be a materials qualification team. And in parallel, there may be a process development team. And then after that, could be a package integration team, which will in the end hand over to manufacturing, obviously passing the gates of purchasing and other key decision makers. So in the early NPI stages, it's mostly material testing team and the process development team or package development team that we interact with.
Ram, thank you very much for taking your time. Thank you for sharing all your knowledge and expertise with us and our audience. I hope they have been updated well with respect to what's new in the semicon packaging ecosystem and the various innovations they can expect from Henkel, right? And if they have any doubts, queries, or feedback, I invite them to post them uh, on our channel, and we'll share them with the Henkel team and get them replied to as soon as possible.
Yeah, again, thank you, Rahul, for having me today. I really appreciate the opportunity to engage with you here and look forward to participating in the semiconductor ecosystem in India. Thank you, everyone.